All right, so normally, as I said before, when we are finding a solution in this particular thing, we're not finding the answer to one particular spot. So that solving that we did the other day, that was kind of just an introduction. When to pass the assessment, it's usually about an interval. So they're looking at when is something higher than this or when is it lower than this. So we get that greater than, less than sign coming on. So we might have something like, make one up, 3 sine 3x is less than 1.5 for x between these two values. All right, so good idea, little sketch. It doesn't need to be really on point. It's just giving you the idea as to whether you are right or not. So 3 times as high, 3 times as many. So I'm just going to draw a sine graph 3 times as many. There we go. Lovely. I'm going to make that 3 and that -3. It's as easy as that. All right. So I've drawn it first. Let's say that that's 2 pi. 3 times as many in the space of 1. 1 goes pi. So I want all the solutions up to here where this wiggle is greater than 1.5. So here's 1.5. Right, so where is it greater? It is greater from here to here. It is greater from here to here. It's greater from here to here. All right, happy with that? So basically all I want to do now is put that into my calculator. Remember that when we are entering this, get into the practice of putting brackets here. Okay, so put it in your calculator, make sure you calculate the radians. The whole lesson with the year 12s couldn't work out what on earth was going on because I needed degrees and I had my calculator in radians. So every period I'm changing between. Back to radians. Right, put it in your graph, put it with the brackets in, so 3 sine bracket 3x bracket. And on the next line, 1.5, change your view window to between 0 and 2 pi. And change your y to between -4 and 4. And draw. And that doesn't look right yet. That's what I've done. Okay. Angle still managed to get into degrees. Right, good. So always try and hope that the picture on the wall looks approximately the same as your screen, okay? Because then you know you're going to get the answers you need. So use your Shift G-Solve intersection button and away you go and you write down the answers. And that gets you achieved. You only need one interval right, but it would be very good to write down them all correctly. So the first one is 0.175, and we write that that's less than x. And technically, we need to have less than signs because we've got a less than sign here. It's not going to mean you fail. All right, if you had a less than or equal sign here and you wrote less than here, they're not going to fail you on that. But to be perfectly correct, we need to match the signs correctly. Yes?
Aren't those bigger than 1.5?
And it's a good idea if you know your less thans and greater thans. So, anyway, go backwards again. So from 0, thank you, artists. Appreciate the fact that you're willing to just yell that out before I get too far. 0.175, and then, so we're actually not finding that at all, are we? We're not finding the black, we're going to find the red. So that's greater than, I've got to change the sign. That would have been an easier one. But now I'm not going to. Admit your mistakes. Right, that's what we're going to find. All right. When is this graph less than 1.5? There's 1.5. It's less than 1.5. Right, it's less than 1.5 here, 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 and here, up to 2 pi, because that's where it stops. Okay? Got it. Right, so keeping going, we've got 0.8732, 2.269, 2.967, 4.363, and 5.061 to 2 pi. All right. So that's how you do it nice and easily on the calculator. It'll give you all your points. All you have to do is read it out off and look very, very carefully at the signs, or it won't be signs, of course, because you're going to find that equation from a whole lot of words, and you've got to interpret whether it's greater than or less than, or when is it further away from or closer to, or any of those sort of words that might crop up. You've got to interpret them into that sign and then find your solution set. Boom. From that, assuming that that all came to me in words and I had to find the 3 and the 3 and probably a +1, I need 3 of those ABCDs to be able to pass. All right, so it's going to have 3 in at least. I've now got achieved in 4 credits at level 3. But we also need to know what's going on, especially if we are looking at doing calculus, and I know a couple of you are actually quite interested in it. So in the exam, they might say something like solve 3 sine x equal to, we're going to put it this time, for 0 to x to 2 pi. All right, I am still going to put this in my calculator and find out there are 6 solutions I'm looking for. But what I need to realise now is I need to look at the symmetry of the graph that I've drawn. All right, so it has symmetry between each of these points. So that little red bit there is equivalent to a little bit red bit there. This big huge bit here is the same as, or I could jump to here, and then I have just that little bit again. All right, so I need to use the points that are symmetrical. So I've got 2 pi here. I know this is pi by 3, 2 pi by 3, pi, 4 pi by 3, 5 pi by 3, 6 pi by 3, or 2. All right, so that at those points, there's symmetry in the graph. And we can use that symmetry to find all our points if we didn't have a graphics calculator, which luckily we do. So what would we do? They're going to say something, if it was a scholarship question, like use the general formula to find. The general formula will be on the formula sheet, and basically it just says exactly what I'm just saying. Use symmetry. So we solve this. Sine 3x equals 0.5. 3x equals sine -1 of 0.5. So put that in our calculator because we need a value there. .5236. Divide that by 3. 0.1745. This one. All right? So it will nearly always find the closest value to the y-axis, and then we have to use that value to find more. So we can find more by looking at it and saying, okay, we're going to add it to pi by 3. So the second solution is going to be pi by 3 plus 0.1745. Which, funnily enough, is not right. That. Good point. Minus 0.1745 times 2 equals. Now it looks beautiful. So we get that 0.873. Right? So not plus, minus. Next one is plus. So we're alternating as we go. So from this one, we're adding on. We found that one, we found that one. We found this one that's adding on, so 2 pi by 3 plus 0.1745. When we put that in our calculator, we'll get 2.269. Then this one will be taking off, so it will be pi minus 0.1745 equals 2.967. Next one we'll be adding on 4 pi by 3. So what we've done is we've taken 2 pi and we've sliced it into 6 pieces. And then we've added and subtracted from each one. We're up to plus. Is there an issue? Have I done something wrong? No? We're happy? Okay. So, on the formula sheet, there isn't another one. On the formula sheet that you get in the exam, it says for a sine that the general solution of sine theta equals sine alpha, then theta equals n pi plus -1 to the power of n alpha. That's what it says on here. And solving a sine one. There's another one for a cosine and there's another one for a tan. But that's the one for a sine. Now what does that mean? It says that if you've solved it and you found out that your answer is alpha, so alpha being the first answer that you get, alpha, beta, gamma, delta, right? So alpha being your first answer you get, then every interval of pi, so our interval of pi was pi by 3. Okay, that was our interval of pi. We'll add or subtract, so -1 alternates. When it's got an even power, we're adding. When it's got an odd power, we're subtracting. So odd power, first answer, after it. Even power, added on. Odd power, subtract it. Even power, added on. Odd power, subtract. And that's what that formula there means. Do you need to know it? No. Why am I telling you?